Okay, today we're going to do another first difference problem. And I have here a couple of data tables, and we're going to start this daily practice problem actually with a little bit of an explanation. So I'm going to explain the difference between these three data tables. I'm going to explain when you can take the first difference, when you can't take the first difference, and when you need to actually normalize the first difference to get velocity. So in the case of our first data table, what I would like you to pay attention to is this first column. And we can see that in this first column, uh, every single t, right? So like every single time, or t, increases by 1. Okay, so every single t increases by 1. That's easy to see, right? Because 0, 1, 2, 3, 4, 5, 6, 7, 8. In this case, right, in this case, we can take the first difference. And not only can we take the first difference, um, also the first difference is velocity. Okay. Remember, the first difference is velocity only because we have time here and distance here. Okay, right? So that t stands for time, that d stands for distance. Now, in this second data table, right, again, pay attention to this t column and notice that every t increases by a fixed amount. And that fixed amount in this case is 2. Okay, in this case, we can still take the first difference. Um, but the first difference isn't actually velocity because the first difference increases by 2 each time. The first difference divided by whatever fixed amount, oops, let's write it like this. First difference, that whole thing, divided by whatever that fixed amount is velocity. Okay, so this kind of I hesitate to call it an equation here because we're not really going to use that as an equation. But if you're trying to get to velocity when you're not increasing by 1, you have to remember to divide by that fixed amount. I have a normalization there. In fact, you're actually kind of doing this on that first data table. It's just dividing by 1, right? Isn't dividing at all. Okay, and finally, this last data table, I think this is going to be perhaps the most important one when it comes to checkpoint 3, because we can't have something like this. Impossible to take first difference. Or rather, like if you take the first difference, it's actually meaningless, right? So in this case, right, you could say, oh yeah, I can do the subtraction. I can, if I extend my data table out here, and you say, oh, but look, like I can subtract here. Look, it's a 13 and it's a 12 and that's 1. Yes, but this doesn't actually mean anything. Because the difference between t is changing, our first difference is meaningless. It doesn't make any sense. So we don't actually ever want to take the first difference when we have a data table looking like this. So um, I wanted to add this. I wanted to add, this information to your kind of suite of knowledge, just because when we do checkpoint 3, we need to make sure there's going to be a temptation uh, to measure distances at convenient times, and a convenient time might not be even increments. But that's something we need to make sure that we are doing in order to be able to take the first difference. So, uh, okay, so now to the problem. We're 5 minutes into the video. Thank you for bearing with me. The problem here is to calculate the first difference of this first box and find the velocity, and then calculate the first difference of the second box and calculate the velocity. Remember, right, in the second data table here, you need to normalize by dividing by a fixed amount in order to get velocity.